Differentiation lesson 8 is on optimization. Optimization means it's all about working out maximum and or minimum values. There's been an optimization question in the exam every year for the last 40 years. It is also the question that most people say that they like the least. Normally because for part A, which is worth 2 or 3 marks, they find getting into that quite tricky. And yet part B, which is normally worth 6 or 7 marks, they normally get full marks. So if this is your worst question and you get 70% on it, that bodes well for getting a very good high result. And in fact, with practice, you'll get into the mindset of how the examiners set these questions and also pick up 2 or 3 marks on part A and therefore get very good marks. It's a question you know is going to be there and you can practice and revise and therefore be good at in the exam. So on page 15 in your notes, example number 1. Farmer has got 100 meters of fencing. He wants to use it to make a rectangular field or paddock or something for his sheep, who knows. All right, and so to get the maximum area possible, he's going to put it against a wall that already exists. If he has 100 meters of fence and ready to assemble, what's the maximum possible area he can make for this field here. These questions always have 2 pieces of information. Start with what the question is asking you to do, but then at some point you're going to have to use the second piece of information to get the whole thing to work. In the first instance, the question is asking me to work out the maximum possible area. So I'm just going to start off in words, because there's nothing wrong with keeping it simple so I can understand. Area of this rectangle here is going to be length times breadth. Now it's part of differentiation, so I'm expecting, and when any time a question's got maximum or minimum, 9 times out of 10 or 19 times out of 20, they will be asking you to differentiate. So I need to do something here to get this into a form of differentiating. So I'm just going to say, well, I'm going to call it A for area. And on my diagram, and if this wasn't on my answer, I'd do a little sketch to show that this is X. This side must also be X. And I'm just going to put L on there for length. You could put another letter if you preferred. So area is obviously, for this field here, L times X. Now, here's where I'm going to have to, quite early on, bring in a second piece of information. Because when I'm differentiating at higher level, there are 2 variables, 2 different letters which can stand for different numbers. And obviously as X is has different values, because I know the overall length, the length here will also have different values. I can't differentiate when there's 2 different letters. I can differentiate 1 letter in an expression, not 2. So what's the second piece of information that I've got in the question? That the total length of fencing is 100 meters. So over to one side, I'm going to say, I know that X plus L is equal to 100. Because that's what I've got here. The question tells me that. I know I need to replace L over here so that I've only got an X term to differentiate. So I'm going to rearrange this to get in the form L equals, make L the subject of the formula, and then I can use that to replace the L over here. So I know X plus L is 100. All right, so that's 2X plus L is 100, just simplifying it. And then let's rearrange the subject of the formula for L. So take away 2X from both sides. L is going to be 100, take away 2X. Now I've got something I can replace the L with in my main calculation. So I'm going to take this over here and say, oh, I now see that area equals 100 take away 2X times X. Let's break the brackets. Area equals 100, multiply everything by x, take away 2x squared. How do I get maximum? That means it's going to be a stationary point if it was on a graph. That means I'm differentiating and setting to 0. So, well, I can either write a dashed x, or same as if I was doing y equals, I'd then put dy by dx. So I'm going to put dA by dx. Same thing, really, because that's the letters the question's using. But my derivative is 100, take away 4x. Remember, make sure you score the mark for stating that you're setting it equal to 0 for a stationary point. And I'll solve that. So it looked like there's one stationary point when x is 25. Not enough to do that, of course, because the stationary point could be a point of inflection or a minimum or a maximum. So I'm going to do a nature table to find out. We said we're going to have an x value, we're going to have a dA by dx, or a gradient, and we're going to say what does the line or the slope look like. And we've said we think that x is 25. Let's check out values less than 25. So I could do 20 or 10 perhaps. But the easiest one of all, since there's just one stationary point, I'm going to plug in 0. Remember, I'm going to plug it into my derivative equation. First equation, if it's a graph, gives me points. Second equation gives me gradients. So on here, substituting in 0, 100 take away 4 zeros is 100, which is definitely positive. So up here, I'm going to say this is a positive reading. The graph is going up. We've already said that if x is 25, gives me a gradient of 0. I'll double check. 100 take away 4 25s, absolutely. So this is here. And pick a number more than 25. So I'll probably just pick 30. 100 minus 4 30s, that's 120, so that's negative 20, a negative answer. And so I get a negative thing for my table here. And so this is a maximum turning point. And that's what I expected, because the questions asked me to work out a maximum possible area. If I got a minimum or a point of inflection here, that would say go back and check my working, I've done something wrong. I will state that that's what I've got. Don't just leave the diagram like that, even though you may think it's obvious. So I'm going to say a maximum, I could say value. I'm going to put turning point just to show that I understand it. We could graph it. Maximum turning point or a maximum value occurs when x equals 25. State that, please. You get a mark for stating that. At this point, sometimes it's tempting to say, I've shown the maximum and I've worked out what x does that, and I'll move on to the next question. Check you've answered what the question asks. The question in this instance did not say what value of x gives the maximum field size. The question said, what is the maximum possible area? So I have to make sure I answer that. So I'm going to say area is length times breadth. The length, well, I know how to get the length. The length is 100 take away 2x. So that's 100 take away 2 25s. The length up here, 100 take off the 2x's, take off the 2 25s. This must be 50. So my maximum area, since area is length times breadth, my maximum area will occur when the length is 50 and my breadth is 25. That works out to be 1,250 meters squared. And the question's done. So to recap, we went with what the question asked me for did a basic formula. I just wrote it in words to start off, just to keep it right. When I found out two different letters that were both variables and I'm only allowed one that's changing its value, I then use my second piece of information to get an expression that I can then replace one of the letters. Then I differentiate, set to 0, solve, get a nature table to check it's a maximum or minimum depending what the question asks, and then make sure I've answered the question. So I'm going to show a second example, a little bit more typical of what's asked in the exam. So take your time, please, and write this into your notes. Example number 2. So we have a square-based display case. The base of it is just going to be wood or something, I presume. Right, but the sides and top are made of glass. The volume of the case has to be 500 centimeters cubed. Right. And obviously the person making the case or wanting the case is going to say what's the minimum amount of glass, because that will presumably minimize the cost. So, typical exam question, they will actually say, show that the area of glass is, and they will give you a formula to work out. And this is often the bit that people don't like. It's worth usually 2 or 3 marks. I know many people will actually go ahead and do part B. They'll say, well, I know how to differentiate, so I will start with this result and I will differentiate it and set it to 0 and show that it's, in this case, a minimum and so on and so forth. We'll answer the question and that will give me the 6 or 7 marks. And actually they're then off to a flying start on what they consider the hardest question in the exam. But actually, as I say, you get familiar with this with practice. Once you do several of them, you get into the mindset of how they do these questions. And then whether you do it first or go back to it and do it second, right, it becomes relatively straightforward many times to get 2, 3 or marks on part A, and therefore to have done very well on the question indeed, because we know it's going to be in the exam, and so we can revise for it. So, I will start with what they're asking me. Again, they're asking me in this question for area. And just in words, what's the area here? Well, it's a square top and 4 rectangles down the side. I'm just going to write for my answer to A, my area is equal to top plus 4 sides. Just keeping it simple. What's the top? Same as the base, x times x. So the area is given by x squared plus 4 lots of, and again, I've not got anything indicated here, so I'm just going to call it h. I could use another letter, but I'll put an h for height. If you didn't have this given, do a little sketch and mark it in, because as soon as you do a little sketch and mark it in, then that shows that this is the working, that you've not got a mysterious h appearing out of nowhere. So that's 4 lots in each rectangle here, base times height, or length times breadth, but either way, xh. I know I'm going to be wanting to differentiate, and as it stands just now, I've got 2 different variables here. I've got an x squared and an x term. That's okay, but now I've got an h. So I need to get rid of this h. How do I do that? Second piece of information. What does the question tell me? That the volume of this cuboid is 500 centimeters cubed. So I'm going to go to one side and record the second piece of information. Volume is length times breadth times height, which will be x times height. And therefore I know, since the volume is 500, x squared h is 500. So h is 500 divided by x squared. I'm going to substitute in my main calculation. This is a of x. How do I know to put a of x? Because that's what it said in the question. The area depending on x. A bit like we use f of x in other differentiation questions. So substituting in x squared plus 4x, and then I'm substituting in my 500 over x squared. Break the brackets and tidy up. A of x is x squared plus 2000, and cancelling down the x with the x squared, 2000 over x. And lo and behold, that's what the question said. If you weren't able to get down to this as an exam technique, and say you got part way down, you may well get marks for working, and you can still go ahead and do part B, because you know to do part B, you start off with the result that they tell you and differentiate. So you would start with this bit here because we know that's the answer we should get. So whether we get it or not, we can still do part B and therefore get lots of marks for this question. Calculate the minimum area. That suggests stationary points. That means differentiate. So for question B, I'll use the same notation as the question. A of x equals x squared plus 2000 over x. Of course, I can't differentiate that as it stands, so I'll rewrite it as x squared plus 2000, bring the x to the top, x to the power of -1. This is still a of x. I don't differentiate anything till I can differentiate it all. A dashed x. I could put dA by over dx, but this is the notation of the question, so I'll just stick with it. It's equal to 2x minus 2000 x to the -2. I'm going to rewrite it, since I know I'm going to be solving it in a little minute, and I don't like the negative index there, so I'm going to put this back underneath. And now to solve it for a stationary point, I'm going to say I'm going to take this expression and set it equal to 0. How do I solve this? Don't like the fraction here, so I'm going to multiply every term by this denominator. So I'm going to have 2x cubed minus 2000. Let's multiply both these terms by the x squared. Multiply 0 by x squared still gives me 0. Two x cubed equals 2000. X cubed equals 1000. What number times itself again is 1000. X equals 10. Must make sure in this case it's a minimum area, because that's what the question said. So once again, a nature table. That's my value for x here. And the slope, or the line, either term will do. I used slope before, I'm just putting in line just to show you can do either. And my table is too clean and the paper is slippy. Please don't tell your mother that I said your table is too clean, or your father. I don't want to get in trouble. Anyway, a dash x, gradient when x is 10, checking in my derivative formula up here. Okay, the easiest one is here, right? And if I try that, 2 times 10 is 20, take away 2000 over, and so on. Does it get 0? Yes, I do. Horizontal line. pick a number less than 10. I'll probably pick 0 in this formula. And then I'd say 2x minus 2000 over. I can't do that. I'm not allowed to say 2x take away 2000 over 0 squared. So for once I can't do that. So pick a number less than 10. I'll pick 1 because I will be allowed to divide by 1. So 2 times 1 is 2. Take away 2000 over 1 squared. Take away 2. So 2 take away 2000 is definitely going to be negative. So it's a negative 1 here. Just looking good for a minimum value. Pick a number more than 10. I will pick 100. 200. Take away 2000 over 100 squared. Well, 2000 over 100 squared is 10,000 up there. So this is a positive. So I'm going to say a minimum value occurs, again I could have put turning point, when x equals 10, because I get a mark for interpreting my nature table. And last but not least, check what the question said. Sometimes it will say what are the dimensions, it will say what is the height, what is x, and in fact this time it said calculate the minimum area of glass required. So the glass was the top plus 4 sides. All right. I'm going to use this expression. I could use the first one here and work out h from over here and plug it in, or I can just jump straight to this one here, which is what I'm going to do, because I think that will be the quickest. So I'm going to say area is x squared plus 2000 over x. Plug in my value, 10 squared plus 2000 over 10. 10 squared is 100. 2000 over 10 is 200. All right, then my minimum area (100 plus 200), 300 centimeters squared of glass. That's how we do optimization.